Hey everybody. Today, you can see the title up on the top of the screen. We are going to go through and solve, okay? Solve right triangles. That is going to require a process. Solving a triangle is actually something very specific. Today, what we're going to do is we're going to take all of our right triangle information, all of our background, and we're going to put it all together. So you can see the first problem that I've asked you. In problem 1, I've specifically asked you to solve for x. And that's all I want you to do. So I want you to pause the video and I want you to give both A and B a shot. We'll come back. We'll see how well we do. This should be a good gauge of where you're at with your right angle trig. Okay? Pause the video now. Okay, we're back. So I'm going to go through and tackle problem A with an idea that this is a review problem for you. Okay, this is just a check-in to see where we're at. You're taking a look at that triangle from your angle's perspective. You recognize it is a right triangle, so you know you've got all of your SOHCAHTOA at your disposal. If you take a look at that 38, the side you're looking for, x, is our adjacent. The other side given to us was our hypotenuse, and you know adjacent and hypotenuse from that angle is cos. So our cos of 38 degrees has to give me adjacent over hypotenuse. That gives you your equation. You can now go through to solve for x. We should be pretty quick on to get rid of your divide by 12. You need to multiply by 12. You'll notice when you take a look up at the problem, there are no rounding rules stated. So we go to our default, which is to 2 decimal places, and you should have got to 9.46 centimeters and you're good. So I would hope that I see that entire purple solution because I would need to see each one of those lines as a part of your solution. Couple small little communication things. Make sure you've got your units on and make sure that you are telling your reader when you are getting a rounded figure. Okay, there we go. If you've got all of that in your solution, great. That should give you a good gauge. Say, okay, I know my SOHCAHTOA. Okay, I want to work my way through B. If any part of A was a hiccup and you want to change anything, here's your opportunity to pause the video and work your way through B. Otherwise, you're coming along with me. So we take a look. The instruction was to solve for x, and we notice there is our dimension for x. Now, I'm just going to zoom in because we don't really care about our solution for problem A. When you take a look, you will notice that that side length of x, or that dimension of x, it's not a part of a right triangle. So if I was to look at that, that is really the side length to the green triangle I just highlighted. It's not a side length to a right triangle. Notice there is no right angle in that green triangle. Okay, so for us to talk about that triangle, what we're going to do is we're going to put a label onto our triangle or onto our diagram. I'm going to label this end point as D. That allows me to look at my diagram. That length of x is now side AD on triangle ABD. So I'm going to use a little bit of headings as I work my way through, just to tell my reader what triangle I'm working with. Just makes it easier to talk. Okay, what I do notice, though, is that I have an angle of 15 degrees here, and I have an angle of 30 degrees here. So this almost becomes one of those problems where, like, I don't know, when you were younger, you were given a worksheet or your teacher threw up a problem and almost asked one of those questions like, how many triangles do you see in that diagram? And not that it was like a difficult problem, but you had to kind of figure, okay, where are all the triangles? I want to go through and I want to highlight them in some colors. Now that I've called that one point, point D, I hope everybody can see this really small triangle of D, B, C. I'm going to highlight that in purple. D to B to C. There's my purple triangle. I would hope that we can also see triangle ABD. We already highlighted that one in green earlier. Hopefully we can see that. But then we also don't lose sight. We have this big triangle ABC if we put those two triangles together. Okay, why is it really useful for me to look at that diagram that way? Well, you'll notice of those three triangles I just highlighted, two of them are right. Notice that little purple triangle, triangle DBC, and my big red triangle, triangle ABC, are both right triangles. And if they're both right triangles, then I can use Pythagorean theorem and I can use my SOHCAHTOA. So what I'm going to focus in on then is the two right triangles. And if I focus in on the bottom side of that diagram, I'm just going to get rid of all of those highlights so we don't get lost in it. Maybe we can see some problem solving here. If I need to come up with this blue dimension, x, then maybe we can see that that value of x is really just the difference between all the way across the bottom, that bottom side of the big red right triangle, subtract the bottom side of my purple triangle. If I took the red length and I subtract the purple length, it has to leave me with x. And there's my problem solving. Okay, I'm going to work my way through using that strategy. So I can get rid of those little labels, and now I'm going to do what my diagram says. What I'm going to do is I'm going to work within triangle ABC. I'm going to put that little heading down because that's going to help my reader to understand some things. Within that diagram, within that triangle, I am looking for my red bottom side. Well, you'll notice that that bottom side doesn't have a label like X. So I have to use my labels on my triangles. Since that red side is opposite this big angle B, then that becomes side B. The side I was given in the problem, my 100, and that would be from an angle of 45 degrees. Notice that compound angle, 30 plus 15, gives me a total angle of 45. Okay, so what does that tell me? Well, if I was to go through and say opposite 45 is B, adjacent is 100, that's my tan ratio. I could say that the tan of 45 is equal to opposite over adjacent. And I built my equation of which I can now solve for B. Okay, you're going to see something really important pop up. When you calculate 100 tan 45, you get exactly 100. No rounding. Okay, I want to highlight something for this, and I know we're taking a side step, but this actually is going to be something that we're going to talk about in detail that can help you to estimate some answers. Why is B exactly 100? I'm going to draw a diagram down below. There is a very special diagram, and we should recognize that from our previous units. There's my square. If I go and I draw on the diagonal of a square, then I hope that we recognize we just put on a 45-degree angle. I want you to take a look at that triangle that I just created in red. If I now have to calculate, based on that red angle, my tan ratio, that is my opposite over my adjacent, then when I go to calculate the tan of 45, I'm going to get whatever this dimension is divided by this dimension. And notice that I put question marks there because I don't know what those dimensions are, but there is something very important. They're the same because it's a square. That my opposite and my adjacent sides are the same for a 45-degree right triangle. So when I go to calculate my tan ratio, I have to get 1. Okay, look back up. Can you now see why 100 times 1 gives me 100? And if we can backtrack to a lot of that, can you see then that when I have a 45-degree angle, my opposite side always has to equal my adjacent? Logically, I can see that that big, long red side B has to be the same as 100. Okay, little side step. Notice you didn't need to know that to do any of that problem. We could calculate it just as we did. Okay, now what I'm going to do is I'm going to switch into a different triangle. I'm now going to switch into, and I noticed that I actually got rid of my label of D. So I'm going to move into triangle DBC to now find that bottom side. Well, you'll also notice that that becomes side B in that triangle because it's opposite angle B. This is why those headings become so important. By putting on those headings, when I now say that the tan of 15 degrees equals B over 100, my opposite over my adjacent, I don't have two side B's that look like they're the same. They're clearly not because you can see with my headings, I'm working within different triangles. So we're going to spend a day in the future working our way through multiple triangles. I don't want anybody to get overly thrown by that. We'll spend some time talking about it. For today, this was problem solving. So I can calculate my B, or find my B, I should say, by multiplying out my 100. Now I'm pushing buttons on this one. When I calculate my 100 tan 15, I'm going to get an approximate of 26.79. There is my meters, and I'm good. So now our logic is going to tell us that to find X, if I now take all the way across the bottom and subtract part way, then that has to leave me with the rest. So if I take my 100 minus my 26.79, then that is going to give me a 73.21 meter distance. There we go. Okay, a little bit of problem solving right off the bat. But I think that should give us a really good gauge of where we're at with our trig. Okay, I'm just going to shrink that down so we can see everything that we did for our intro today. I want to highlight, we did not solve a triangle. Okay, look back at your instruction for today. We solved for X. Now what I want to do is I actually want to follow the title for today. What we're going to do is we're going to jump in now and solve triangles. Okay, this is going to take quite a bit of work, but I want you to see the instruction. The question says, solve the following triangles. If I did not write the following triangles, and I simply said solve, and you were given a triangle, the instruction is the same. So what does it mean? Well, to solve a triangle, what you need to do is find every piece of missing information. So to make sure that we're clear, take a look at the diagram in A. You have triangle ABC. What you have been given in the triangle is angle A, angle C, side C. Everything that I just circled in red. What is missing? What is not labeled on that triangle? Well, angle B is not labeled. Side A is not labeled. And side B is not labeled. What I just highlighted in blue, that's what you need to find. In order to solve a triangle, you have to find every piece of missing information. More importantly, to solve a triangle, it means you have to list those properties that are missing. Doesn't mean label them. So what I want to do is I want to go through the diagram in A, and then I want to kind of let you go a little bit today. We're going to cover a lot of concepts today. It's all based on your background stuff. But we're going to have a lot of, how would you say, policies and procedures. We're going to have a lot of details that we're going to have to examine when we go through. So let's jump in and let's solve A. Okay, when you see your triangle, you can see everything highlighted in blue. My advice to you would be, find whatever you can find right now that doesn't require technology. What I mean by that is, find whatever doesn't need a calculator. Now, what I want to do is I'm going to go through what your solution should look like. We're going to find blue. That means everything that I write in blue, I would have to see as part of your solution. I'm going to put anything in green, what I wouldn't have to see. Okay, let's start it off. Well, I think the easiest thing to find right now would be angle B. It does not require technology. Because I have two angles inside of that triangle, that means I can find the third. I do not need to see this, but I'm going to write it in blue. Like, I'm almost breaking my rule right off the bat, but I'm going to write it in blue because I think it's that important for you to write. For me to find angle B, I know that that is 180 minus the sum of the other two angles. We know that because we know all three angles have to add up to 180. So to find the one that's missing, take 180 minus the other two. I don't need to see this line, but it's a nice line to put in. And now when we calculate that, you're going to get 35 degrees. I technically don't need to see the first line, but I would write it if I was you. What I want to highlight about what I said about listing properties, if all you did was on your diagram, found 35 and wrote 35 in for B, you would not earn full marks on that solution. Solving the triangle means listing the properties. So make sure that you list it out. Don't just label it. Okay. I'm not even going to label that on my diagram because I don't need to. I'm going to keep my highlighted portion in. Okay, now that I have angle B, now I'm going to move on to find side A or side B. Notice I'm going to need to use some trigonometry on that. A word of advice. Use the information that was given to you as much as you can, because you know it's perfect, because you know it's correct. Okay, what do I mean by that? Well, I could go up and I could use the fact that angle B was 35, And now that I know that angle B is 35, I could find side A or side B using my hypotenuse and using SOHCAHTOA. I wouldn't do that if I were you. Just because it is possible that you made a mistake when you went through and you found B. And if you made a mistake and then you use that wrong value, then everything else you find is going to be incorrect. So my advice to you is always use the given information whenever possible. Secondly, use exact information whenever you can. Exact. That's why it would have been okay to use angle B, because angle B is exactly 35 degrees. It wasn't rounded. Do not use rounded information if you can avoid it. And then I'm going to put a little asterisk there. We'll come back and we'll talk about that. But don't. If you use rounded information is a little bit off. If you then go and take that information that's a little bit off and you use it somewhere else, well, now you're more off when you go and round that. So what we want to try to do is be as exact as possible. Okay, I now have angle B. So what I'm going to do is I'm going to look back on my diagram and I'm going to use whatever information was given. They gave me angle A. That's the perspective I'm going to look at my triangle from. Okay, you could find A or B first. It does not matter. I'll find A first just because alphabetically it comes first. I really can't stress enough. It doesn't matter which one you find first. I'm only finding A first because alphabetically it does. Okay, from my perspective, from that 55 degrees, side A is opposite, and the diagram gave me the hypotenuse. So opposite and hypotenuse is my sine ratio. So the sine of 55 degrees is going to equal opposite over hypotenuse. I'll make the assumption that we are very quick to solve that. So we can multiply out our 25. And now I'm going to calculate that. Same thing as we discussed before. There is no rounding rule in the problem, so I follow my generic rounding rule and round to 2 decimal places. Put on my units, and I am good. Okay, I would need to see all 3 of those lines. We've already discussed why. Okay, if I slide that down a little bit, now I can go and find B. I'm going to look at my triangle from the same perspective, from that 55 degrees. Side B is now my adjacent side. I was given hypotenuse, so that is my cos ratio. That is adjacent over hypotenuse, and I am good. Okay, I don't even need to see my diagram anymore. I'm going to slide that up. Now I'm going to go through, multiply out my 25, and now find my approximate. Same thing, my rounding rules are to 2 decimal places, and I get approximately 14.34 centimeters. Okay, there we go. All I'm going to do right now is just box in some stuff. Now you can see the whole diagram, just so, let me get rid of that little X I still had there in my 35. Just so you can kind of see the 3 parts we did. What you did in the first step, you found angle B. Then you found side A. Lastly, you found side B. And there is your full solution. You're done. Nice. Okay, I want to talk to you about a check that you should be following every single time you go through to solve a triangle. And what this relates back to is something you should have discussed in grade 9. It's something really important that relates angles with opposite sides. And really, this is just a logical check. I hope we recognize that when you have a small angle, like I just produced in A, that makes small opposite sides. But when I have a big angle, then that produces a larger opposite side. The closer two rays are together, like in the red diagram, that's going to form a shorter opposite side. The farther apart two rays are, like the green one, the big angle, makes big opposite sides. Hopefully pretty logical. I'm going to use that red and green as a check back on my diagram. To do that, I'm going to label some stuff you would never need to. So you don't need to ever put this on your diagram. You could just look at it and be able to tell. Okay, I'm going to zoom back in. My angle B was 35. Now, my side A was 20.48. And my side B was 14.34. If I take a look at that diagram, what I need to say to myself is it proportional? What that means is, do small angles give me small opposite sides? Do big angles give me big opposite sides? So let's take a peek. If you look on your diagram, the biggest angle in there is my 90 degree. That should give me the biggest opposite side. Yes, that's my hypotenuse. Good. My next biggest angle is the 55 degree angle. So it should give me the next biggest size, which should then be the middle side length. Good. My smallest angle gives me my smallest opposite side. Okay, at least from a proportional standpoint, my triangle matches up. I think that probably costs you, 10 to 15 seconds. At the end of a problem, you going through and spending 10 or 15 seconds to make sure your triangle is proportional, I think is well worth it. Okay, there we go. We just solved our first triangle. I want to now jump into problem B. We don't need A, so I do not have to keep that whole solution there. There is my diagram in B. You'll notice you're working on triangle DEF. Okay. I want to walk through this one. I know I said I was going to let you go, but I want to walk through this one together because there is something very important for us, and this comes back to that little asterisk that I mentioned earlier. Okay. You take a look at what information was given on the diagram. Angle E, side F, side D. What you need to find: angle D, angle F, side E. Okay, you need to find those three blue things. Now, what I want to talk to you about is the part about exactness. How can we get as close as what we can get to? That's what we're on the hunt for, as close as we can get. Within reason. And this becomes one of our asterisks. It's the amount of work we have to do. Okay, I want to walk through. For me to find side E, and by no means am I saying you have to find side E first, but for me to find side E, I could have done that in grade 8. I have a right triangle. I know two sides. I can find the third by using Pythagorean theorem. In the top right corner, I'm going to find side E. Now, I could do my c squared equals a squared plus b squared and write all those in, or in this case, d squared plus f squared. But I think we should be pretty solid to jump some stuff. We have used Pythagorean theorem so much to find right sides or hypotenuses of right triangles. We used it to find the side length of a line segment. I think we should be quite comfortable to jump to that it has to be that. In fact, we should be so comfortable that we could jump straight to this. The only thing I've got to do a little calculating on is what's 8.5 squared? There we go. So you go ahead, you add on your 36. Now, that's bad form. We've got decimals underneath, but we're going to calculate an approximate anyway. If I find my best version of my approximate, I need to take the square root of that. And when I do, I'm going to get approximately 10.4. It's 10.404, blah, 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 blah. We follow our rounding rule, 2 decimal places, put on my units, and I'm good. Okay, that is the best answer I could get for the side length of E. Okay, let's set that aside. If I went through and I found angle D or angle F first, then I might take a different approach. Okay, angle D, angle F, it does not matter which one I find first. I'll follow the same rule. I'll find D first just because alphabetically D comes before F. If I put my focus on angle D, then the side lengths I've been given are the 8.5 is opposite, the 6 is adjacent. I should be good. That opposite and adjacent is tan. So I'm going to calculate my tan ratio. You'll notice I need to find an angle. So I need to go backwards. That means I need to find my inverse of 8.5 over 6. You'll notice I put that in green because as we've discussed earlier, you do not need to show me that line. You now go through and calculate that angle. I'm finding an angle. There's no rounding rule given. That means my generic rule is round to the nearest degree, and there's 55 degrees. Okay. I am going to go through and I'm going to put something on my diagram right now. If I went back and I labeled my D as 55, I want you to notice my triangle starts to look an awful lot like the one in A. Like I have a 55-degree angle right now. And if I have a 55-degree angle in there, well then, hey, I could use SOHCAHTOA to find E. Okay, I'm going to put down an alternate solution for E. Let's say that my focus is the 55 degrees. Well, now I've got 2 side lengths I could use. I could use the 6, I could use the 8.5. I don't know which one I want to use. I'll use the 8.5 just for the sake of it's a cross. I don't know. So I go through now and I say opposite and hypotenuse, there is my sine. So if I calculate the sine of 55 degrees, that has to give me 8.5 over E. I could now multiply out my E. You'll notice I put that line in green because, again, I do not need to see it because I should be good to multiply it out and then divide out my sine 55. Now this becomes a button-pushing exercise, so I'm going to go through and I'm going to calculate 8.5 divided by the sine of 55. And I get 10.4 meters. Well, I don't really. I only do if I round to 1 decimal place. My actual answer to 2 decimal places would be that. And you'll notice my 2 answers are off. Now, you might look at it and say, come on, 2 100ths of a meter? Like that's 2 centimeters. That's not that big of a deal. Well, if our units were kilometers, that's a significant deal. Now we're talking about 20 meters off. If you're building a bridge, your bridge coming up 20 meters short is very important. Clearly, something happened. This is what I mentioned earlier to you when I said, don't use rounded information. I want you to notice that when we calculated angle D, we rounded. Now I use that rounded information to find something else. My problem is a little more off. Notice when we found E using Pythagorean theorem, that was as exact as we could be. All the information we used in there was exact. That is the outcome of using rounded information. So I want you to be conscious of that. Use exact information. Use the given information as much as you can to solve for things. Okay, I can get rid of all of that stuff that I just boxed in and wrote, and I'm going to get rid of that extra solution for what we found because you can already see the impact of it. We shouldn't have included it. Okay, now you take a peek. I'm just going to put a couple little markings back in. There we go, and we're good. Now I need to find angle F. And here's where the asterisk comes in. If you listen to everything that I just said to you, then we should be saying, well, okay, then the tan of F is that opposite divided by that adjacent. But you don't have to do that. That is using the exact information we've been given. That is perfect. However, it's extra work. So one of the little asterisks that we have when we say you should always use exact information is if you can do it now without technology. Notice I'm going to have to push buttons to calculate my orange. I can find F without pushing buttons. So because of that, you're allowed to. And in fact, you're recommended to. That I would hope that I would have a bunch of people that would then say, well, now I know two of my angles inside of my triangle. That means I can find the third. And therefore, pretty quickly, you come in on F being 35 degrees. There we go. Okay, I'm going to just try to shrink this down and put everything on the screen. I am hoping by taking a look at those two problems, you now get a sense of how we can solve triangles. Okay, always use exact information as best as you can. Whenever you can, use exact, unless that means that you can do it without technology. Then you're permitted to do so. Use big angles, big opposite sides, small angles, small opposite sides as confirmation. We should be able to use that same check on triangling problem B. And I think we're then good to solve triangles. Okay, now what I want to do for the rest of our time, I want you to have a shot at going through and solving these triangles on your own. And I'm hoping this just becomes kind of a cumulative day for what you've done over the past couple. Okay, let's jump into our next problem. Okay, I think it's about time we can jump in and start playing through this one on our own. I'm not saying we're going to be at the point of no hesitancy, but I really do think that this should start to feel more and more natural. So I would be expecting for us to match up with the same solution in the end. Okay, that would be my expectation. If we're not, then we're missing something, and we got to make sure that we clear that up. Okay, I want you to take a look at the triangle I've given you in C, because we just have one other topic we got to talk about. What happens if I give you a triangle with no labels? Okay, do not work through that triangle. You'll notice there is no name to it. Do not work through it without labels. You go and you call that triangle whatever you want. Triangle ABC, triangle DE, who cares? But you make sure you label it so your reader has an understanding of what properties you're finding. Okay, I think it's time for you to go through. We will match up in the end. Okay, pause the video now. Okay, we're back. Just for some variety, how about I call this triangle X, Y, and Z? Because it's a Z, I'll put a little line through the middle so you don't think it's a 2. Okay, hopefully you were good then to go through. You noticed you had a right triangle. You were given an angle, given a side. Okay, we're off to the races. Because you have 2 angles in there, everybody should have been finding that first angle. That third angle. So if I take my 180 minus the sum of the other 2, I'm going to put this all in red just because it is pretty quick for me to be able to go through. I would expect you to write all of those. Like, seriously, put it down. Okay, we now have angle X. I need to find side Y and side Z. I do not care which one of those I find first. I'll find Z. How about I find Z first this time to go against the alphabet? So, for me to find side Z, I know that I've been given my adjacent side to the 48. Side Z is opposite. Opposite and adjacent is tan. So the tan of 48 is my opposite side, Z, over my adjacent side, 12. Okay, I can multiply out my 12. And now, same thing, no rounding rules, round my sides to 2 decimal places. And when I do that, I'm going to get approximately 13.33 meters. Okay, now that I know side Z, I'm left to find side Y. I go back to my given information. From the 48, my 12 is adjacent, side Y is my hypotenuse, adjacent and hypotenuse is cos. So the cos of 48 is my adjacent over my hypotenuse. And same thing. I hope we're okay if I jump straight to this line by now. We should have had enough practice that I can multiply out my Y, divide out my cos 48. That is going to get me an approximate. And again, we should all be good on our keying sequence for this. So by this point, we should all be comfortable to go through and find a 17.93 meters. And there we go. Okay, if this was a test question, you better bet that I'm going to go through and do a little bit of a check just to make sure proportionality on my triangle. Okay, I take a peek. My biggest side has to be my hypotenuse. Yes, that matches up. Oh, that was a 9.3. Not that it matters for my check. Okay, my smallest side has to come from my smallest angle. So because I have 42 and 48 as my other, its opposite side better be the smallest. And it is the middle side. There we go. Like I could even go a little farther with my check. Notice 48 is a little bit bigger than a 45-degree angle. And I know on a 45-degree angle, these sides are the same on my right triangle. 45 is the perfect diagonal of a square. So the fact that a little bit bigger than 45 means 48, well, then that means that this opposite side should be a little bit larger than this adjacent side. And you can see that back up on my triangle with the relationship between 13.33 and 12. Okay, if this was me solving this triangle on evaluation, I am super confident in what I found. I'm moving on to the next problem. Okay, I am hoping that you matched up with everything that we had, that you gave me that red solution regardless of what labels you had on your triangle, and that we're feeling more comfortable with solving triangles. You can notice today really is a sum up of everything we've been doing. Okay, jump in, get some practice, try to make this as automatic as possible. Best of luck.